Section 5.2, this is dealing with just bisectors in triangles. So these would be angle bisectors and perpendicular bisectors. Alright, so a little bit of vocab. A perpendicular bisector. Bisector is in the middle. Perpendicular means it makes 90-degree angles. So this is a segment that cuts through the middle of another segment at a 90-degree angle. Equidistant, equa being equal, so these would be equal distance. And then an angle bisector, this would be a segment in the middle of an angle that cuts an angle in half. Alright, you need to know what these are before we can talk theorems. So, perpendicular bisector theorem and converse of perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. It makes a triangle is what happens. And the converse, if we have a segment and there's a point that's equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. And you'll see this when we do examples. Alright, so the first example, this segment CD is a perpendicular bisector because it's in the middle, because both sides are equal, and it makes a 90-degree angle. So it's a perpendicular bisector. So if there's a point that is on the perpendicular bisector, like the theorem said, then it is equidistant from both endpoints of the segment. So that means CA is the same as CB. And that means the same thing for D over here, right? These are equal. So DA is the same as DB. Alright, angle bisector theorem. If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. And it has to be a perpendicular distance. You can't have an angled distance from that point to the angle. It has to be a perpendicular distance. And then the converse of the angle bisector theorem would just be if there's a point inside the angle and it's equidistant from the sides of the angle, then that point is on the angle bisector. Alright, so in this picture, CF is an angle bisector because it creates two equal angles up here at the top. So that means these sides are equal, that means these sides are equal. Okay, so we can do 5x equals 2x plus 24. And then we solve. So subtract 2x, and divide by 3. So x equals 8, but we want FD. So FD equals, we got to plug our x in. So we do 2 times 8 is 16 plus 24 would be 40. Okay, a lot of numbers in this chapter. Alright, and our last one for this lesson, we want the value of x, and then the measurement of CG, and the perimeter of the quadrilateral. So let's go one step at a time. Value of x. See how G has a perpendicular line coming to both sides of the big angle? So then these are equal to each other. So we take 2x minus 4 equals 4x minus 16. And we'd solve that. So I'll subtract 2x over, and I'll add 16 over, and then divide by 2. So I get x equals 6. That's one of the answers we need. We need CG. So we're going to have to plug that back in. So we'll take 4 times 6 minus 16. It'd be 24 minus 16, so that'd be 8. And then I want the perimeter of the quadrilateral. So that would be, let me highlight it in green, this shape right here. That's the quadrilateral. Okay, so we know CG is 8. We figured this out already. That means this piece has to be 8 because they're equal. And then here we'll plug in our 6. So 3 times 6 is 18, minus 2 is 16. And then BC has to be the same as AB because they match up in the congruent triangles. So now we just need to add everything together to get the perimeter. So we'll take 16 plus 16 and get 32, plus 8 is 40. plus 8 is 48. We don't have a unit, so we can't put any units on it. All right.